Hello everyone and welcome to this week's webinar. I am delighted today to have with me Robbie Strickland, the Software Development Manager at the Weather Channel. Robbie has been using Apache Cassandra for quite some time now. He is a very prominent member of the Cassandra community. Robbie, we really thank you very much for your continued support of Apache Cassandra and the community. A couple of housekeeping items. If this is your first webinar with us, Robbie will take questions at the end of today's session. Please use the Q&A tab inside of WebEx and ask your question there. And we will get through just as many as we can at the end of the session. So without further ado, I will hand over to Robbie Strickland, who today is going to talk to us about Spark and Cassandra together and some of the improvements that he has seen with that combination over Hadoop and MapReduce. So delighted to have you with us today, Robbie. Thank you very much.
Thank you very much, Christian. I appreciate you guys joining me today for today's webinar, which I am calling the New Analytics Toolbox. I plan to talk about how the state of big data analysis art has changed over the last couple of years. Hadoop has dominated the space for many years now, but there are actually a number of new tools that are worth a look now, whether you're new to the analysis game or whether you've been using Hadoop for a long time. My name is Robbie Strickland, as Christian said. I'm the software development manager on the data services team here at the Weather Channel. My team builds the back-end APIs and analysis services that power weather.com, the TWC mobile apps, and a host of other external customers. A large majority of the weather data consumed on all platforms actually originates with us. So one of the first questions you might ask is, what's wrong with Hadoop? You know, I'm using Hadoop now, it works fine. I've invested all this time and money into it, so what's the big deal? Well, for starters, it's 11 years old, which is kind of hard to believe, I know. Some of you are thinking, wow, I'm a little bit late to the game, to which I would say this is good news for you because you're unencumbered by any existing technology investment. It's also relatively slow and inefficient. Even though it was groundbreaking at its introduction, it's by today's standards, it's pretty slow and inefficient. And the primary reason for this is because everything gets written to disk, including all of the interim steps. And in many cases, you need to create a chain of jobs to perform even simple analysis. If you've ever actually written any MapReduce code, you also know it's not the most intuitive API. It's easy to get things wrong and pretty hard to test. And the cost of getting it wrong can actually be pretty high. And one of the reasons for that is that there's actually a lot of boilerplate. So there's a lot of code to do even very simple tasks. This is improved with tools like cascading, Pig, Hive, etc. That's really just more evidence that the core API is inherently burdensome. And if you've used this stuff, you can see that if that weren't enough, it can be difficult just to get the thing working. It doesn't really do anything out of the box. You have to read a lot of documentation, create a number of config files that aren't intuitive, and fire up a bunch of separate processes just to get it running on your local machine. So the good news is, actually, we're seeing a new crop of tools that are designed to solve many of these problems. This is a list of some of the more popular choices, but the Hadoop ecosystem is already suffering from an overabundance of bolt-on components to do this and that, so it's easy for the really revolutionary stuff to get lost in the shuffle. So let's quickly break down these options to see what they offer. Cloudera's Impala and Apache Drill are both massively parallel query processing tools. They're designed to run against your existing Hadoop data. Basically, they give you fast SQL-style queries for HDFS and HBase, with the theoretical possibility of integrating other input formats, although I'm not aware of anyone actually having done this successfully with Cassandra to date. There are also a number of vendors that offer a variety of analysis tools, which are mostly cloud-based solutions that require you to send them your data, at which point you're able to run queries using their UIs or APIs. Spark and its SQL query API, on the other hand, provide a general purpose, in-memory, distributed analysis framework. You deploy it as a cluster and submit jobs to it very much like you would with Hadoop. And lastly, Spark is essentially Hive on Spark. It uses your existing Hive metastore, but it executes the queries on your Spark cluster. At Spark Summit a few weeks ago, it was announced that Spark will actually be replaced by Spark SQL. So which tools should you use? Well, actually, you don't really have to choose only one. Most of the major Hadoop vendors have embraced Spark, as has DataStax. So it makes it really an ideal Hadoop replacement. Or if you haven't started using Hadoop, at this point, it makes sense to simply redirect your efforts towards Spark instead. There's been a lot of investment in Hadoop connectors called input formats, and these can all be leveraged in Spark. So you can still use your Mongo Hadoop connector, for example, inside Spark, even though it was designed for Hadoop. And even though it makes use of Hadoop components, you actually don't even need Hadoop installed. You will need a distributed file system, and HDFS is a fine choice for that, but Hadoop is not a hard requirement. And also, unlike Hadoop, Spark supports both batch and streaming analysis, meaning you can use a single framework for your batch processing as well as your near real-time use cases. And it also introduces a fantastic functional programming model, which is arguably better suited for data analysis than Hadoop's MapReduce API. And I'll show you the difference with these in a minute. And since I assume you're interested in how well this all works with Cassandra, the good news is you don't even have to use the Hadoop input format, as DataStax has built an excellent direct Spark driver. So I'd assume many of you are either using Hadoop now or you're planning to use it soon. So let's take a quick look comparing it with Spark. For those unfamiliar with what it looks like to write MapReduce, and maybe to cause a little PTSD episode for those who have experience, let's look at a simple MapReduce job. The use case for this job is our new social weather feature in the Weather Channel mobile apps, where users can report their current weather conditions. This data is stored in Cassandra, and we want to create a simple histogram of check-ins by hour, which is nothing more than bucketing them by a rounded timestamp. The first thing you'll notice is all the imports. That's really a lot of imports for a rudimentary job, where we really just are using the basic libraries, nothing fancy. And we'll go about configuring the job, starting with parsing our command line args, and finish off the config with another short 50 lines or so, which is a little bit ridiculous in my opinion. And after that, we create the mapper, which groups all the input keys by hour, pretty straightforward. Then, of course, we have to have a combiner, or this job will take forever. This tries to pre-aggregate the counts before we ship it off to the shuffle stage. And finally, we aggregate all the hours and add up the counts in the reducer, then output them to Cassandra. 130 lines of code later, we have grouped our check-ins by hour. In case you weren't counting, only 5 lines out of that 130 were actually devoted to our histogram logic. The rest was all Hadoop cruft. And now Spark. Let's have a moment of silence as we mourn the death of MapReduce. Okay, mourning over. As you can see, we've reduced our code by 107 lines. We now have 2 imports, 2 lines to configure the job, and then we're right into our logic. There are no byte buffers to parse, and the logic is very easy to understand. And we'll go over this in a little more detail in a minute. So what is Spark exactly? Well, Spark is an in-memory cluster computing framework. It's built in Scala, and which means it runs on the JVM. It can be 10 to 100 times faster than Hadoop MapReduce, primarily because it runs in memory and it avoids all the disk I/O. And as you saw in the brief glimpse of our sample job, its API looks a lot like the Scala collections API, except that you're working with large distributed data sets instead of just the Scala collections. It has native language bindings for Scala, Python, and Java, and there's a separate project called Spark R that's actually designed to enable R on Spark. And if you haven't used R, R is a fantastic language for statistical analysis and machine learning. It also offers stream processing capabilities using the same collections API, so you only have to learn one paradigm instead of multiple paradigms, which can be pretty useful if you're used to Hadoop. And it also supports all the existing Hadoop connectors. Interestingly, too, Spark offers some additional features, including a native graph processing library called GraphX, as well as a machine learning library called MLlib, which is really what Mahout always wanted to be on Hadoop, but really never was, right? And it enables SQL queries via Spark SQL over any Spark collection, so there's no additional bolt-on tool or query framework required. And if you're a fan of Amazon's Elastic MapReduce, you'll be happy to know that you can enable Spark out of the box on an EMR cluster. It's simple configuration. And one of my favorite features of Spark is the ability to join data sets across multiple disparate data sources, as we have numerous here at PwC. Imagine doing joins across Cassandra, Mongo, and HDFS data in a single job. It's quite powerful. So now that we've looked at kind of what Spark is, let's take a look at how Spark integrates with Cassandra. DataStax has recently open sourced a fantastic Spark driver that's available on their GitHub repo. It gets rid of all the job config cruft that early adopters of Spark on Cassandra previously had to deal with, and frankly, for most of the other data sources out there that you have to still deal with. But there's no longer a need to go through the Hadoop API at all. It supports server-side filters, basically where clauses, that allow Cassandra to filter the data prior to pulling it in for analysis. Obviously, this can save a huge amount of processing time and overhead, since Spark never has to look at the data you don't care about. And as with the Hadoop integration, it knows where your data lives on the cluster, and it will try to load data locally if possible to avoid network overhead. Spark still does require a distributed file system of some kind for checkpointing, which is a low overhead usage. Personally, I find it useful to have HDFS running so I can throw unstructured data into my analysis cluster right alongside my Cassandra data. So what does this all look like on a physical cluster? Well, let's start by looking at an analysis data center running Cassandra with Hadoop, since many people are running this today. As you can see, you have your Hadoop master with the name node, secondary name node, and job tracker, then your Cassandra ring with co-located data nodes and task trackers. This is the canonical setup for Hadoop and Cassandra running together. Spark has a similar topology. Assuming you're running HDFS, you'll still have your Hadoop name node and secondary name node and data nodes running on each Cassandra node. But you'll replace your job tracker with a Spark master and your task trackers with Spark workers. It's also worth saying that you can run both Hadoop and Spark co-located on the same cluster, and they don't override each other. So let's talk about what it actually looks like to build a Spark application. Here's a high-level view. The main entry point is the Spark context. The context takes an instance of the Spark configuration, which defines the job and task properties. The Spark application will then load data from the data source and serialize it into a Spark RDD. And we'll talk about what an RDD is in a minute. Next, we'll perform a series of operations on the data in the form of transformations and actions. And finally, we can save or display the resulting data as calculation. So what's an RDD? Well, an RDD is a resilient distributed data set. It's a distributed collection of items partitioned across the cluster, similar to the way HDFS blocks your data across the cluster or Cassandra hashes it up. It has an API similar to that of the Scala collections API to operations in the form of transformations and actions on the data. All operations are performed lazily across the cluster, and they're not executed until you use them. RDDs are also a key component to Spark's fault tolerance. RDDs can recalculate values from any step in the job in case of worker slowdown or node failure. Spark will actually automatically detect the failure and redistribute the work to other nodes in the cluster. Transformations produce new RDDs, while actions require the full materialization of the records to produce a value. And this is often very costly, so it's important to understand the difference. So here are some examples of transformations. So things like filters and maps and flat maps, which if you're familiar with functional programming, are all very commonly used functions. And then actions like collect and count and fold and reduce. So those actually require the materialization of the data on the at the time that they're called. So here's an example of a transformation and an action. In this case, we apply a filter to produce a new RDD of persons above the age of 17. And next, we materialize the RDD of people to obtain a count. But one thing you'll notice is that if you're unsure about what's a transformation and what's an action, the transformation always produces another RDD, and an action typically produces another type of collection. So here's an example of the Cassandra and Spark integration using the Spark Cassandra connector driver. In this example, we load data from the persons table in Cassandra, and we serialize it into an RDD of type person using the Cassandra table method. Next, we filter all persons over the age of 17, and then finally save the RDD back to Cassandra using the Save to Cassandra method. For those new to Spark and Cassandra, this is very powerful and skips a lot of the steps previously required through older drivers. So let's do a quick demo.
And Robbie, we're still seeing your demo slide up. Don't forget to switch to share desktop.
Working on that now.
I love the live demo portion. It always adds a little spice. There we go.
We see it?
Yeah,
okay,
great.
All right, so what I'm going to show you guys here is what it takes to bootstrap this so that you can get it running on your local machine and play with it. And the first step, and I'll show you here, what I've got is I have downloaded the Spark Cassandra connector, I've downloaded the Spark 102 tarball, and I have built the Spark connector, and I have unzipped the tarball into my local drive, into this directory. And so what I'm going to show you really quickly here is what it takes to configure it once you've got these things downloaded. So if we go into our Spark directory here, we can take a look at the configuration file. And actually, if you don't have it already, you'll have to create this file or you'll have to copy it from the template. And you'll see here I've added the Spark class path into my environment. So the Spark class path, on the class path, I've included the Cassandra connector assembly. So that way we can have access to our Cassandra connector from Spark. And then I'm able to go into the Spark shell, which is in the bin directory. Once it loads up here, the first thing I want to do, you'll be able to see as it comes up that I have a Spark context available as SC. So the problem is this default Spark context doesn't have some of the configuration we need. So the first thing we'll need to do is stop the Spark context. And once we stop it, we'll want to import our, and this is, for those of you who aren't familiar with Scala, this is basically just a Scala REPL that's got all the Spark trappings already included. So the first thing we'll want to do is import our DataStax connector, and then our Cassandra row, because that gives us access to some of the additional features on the Cassandra RDDs. And then we'll want to import our Spark related classes so that we can use those and reconfigure. And then the next thing we'll do is we'll create a configuration that sets our Cassandra host. And this is just a seed in the cluster. So in this case, it's localhost. And then we'll create a new Spark context using the configuration we just set up. So now we're ready to go. We can do some work. So the first thing we want to do is we're going to use the same, the data set that I spoke about earlier, which is our check-ins, all of our social check-ins, and we'll grab them from from the weather check-in, WX check-in, key space, and the geo check-in _ perm table. That's what we're doing there. And so just so we can see what these look like, we'll we'll take the first 10 of them and we'll print them out onto the console. So you can see we run through a few of these guys here, and we can see what they look like on the console. So let's see now what it looks like to interact with this data set one at a time. So we can grab our first record here. Okay, we see we've got one record here, this guy right there. And what it looks like to get a field out of it. So we get the time field out of it. Okay, so we got a time field, looks very much like old JDBC type stuff here. So get our condition phrase. So now what if we want to actually, because one of the problems we've got here is we've got all this data and maybe we only want a few fields. So instead of grabbing all of the data, what we can do here is we can actually do a select. So you can see I've got my Cassandra table, and now instead of just giving it back to me the way it wants to give it back to me, I'm actually going to cast it into this tuple here of a string, a long, and a string. And then I'm going to add this select so that I only get user, time, and condition phrase. So now we've got that. And we can see what it looks like now. A little bit easier to read now. So now we've got tuples instead of those Cassandra rows we were returning before, which were a bit raw. Now the next thing we can do is we might say, okay, well, I actually don't want to look at all of my check-ins. I only want to look at the ones that are later than a certain time. So in this case, I'm going to add a where clause here where I can filter based on time greater than a certain value. So now we'll get all those guys. And we'll print those out as well and see what those look like. Okay, so we've got a few of those. And then what I want to do is I actually want to find out everybody who reported sunny. And so I'm going to come over here into my, I'm running CQLSH here, and I'm using my weather check-in key space. And so now that I've got this open, we can do a describe and see what's here. Okay, so we've got a number of things here, and we actually need to create a new table here called sunny check-ins, because we only want our sunny check-ins. So we're going to create a new table here called sunny check-ins. And then we're going to come back into Cassandra, back into our Spark shell, and we're going to do a filter. So we can take our check-ins and we can apply a filter where our condition equals sunny. So as you can see, this is a good example of something that returned in RDD. That filter hasn't been applied yet. So now let's take a look. Let's see if we can see a few of these. All right, now that we're doing a take, we actually have to do some work. So we can see we filtered out the sunny records. And as you know, if you've worked with Cassandra very much, that's not something that's possible to do in the SQL shell. So let's actually grab those guys and save them right out to Cassandra. So now it's actually going to go through and do all that work and save all of those guys out to our new column family, our new table we created in Cassandra. So we can take a look at that in a little while when that job is done. For now, let's head back and talk a little bit about Spark SQL. We can share. Just a minute, technical difficulties.
In your slides. Hey, Robbie, I think you're on mute, but we can see your slides again.
All right, so this is an example similar to the one we just showed, except we're using Spark SQL to filter the person's RDD. Like before, we load the data from Cassandra into a Spark RDD, and we immediately use the register as table method to create a table named persons. This will actually allow us to issue SQL queries against the person RDD. We can filter out all persons above 17 using SQL and print the results. And this actually works against any Spark collection, any Spark RDD. So it's not just Cassandra data. Now let's take a look at Spark streaming. And while this isn't directly related to the Cassandra integration, it is central to Spark's functionality and some of its additional features. With the Spark streaming context, we can now process streams just like any other data. Spark actually slices up the stream and produces RDDs on a defined interval. Because it simply produces an RDD, you can perform the same operations on the stream source that you would on any RDD. And it actually supports a variety of sources. For example, queues like a Kafka queue, you can get a Twitter feed, you can get your data from Flume. There's quite a few built-in sources, or you can actually create your own as well. So in this example, we want to filter tweets we think may be happy tweets. So we'll define a set of happy words. We'll use the Twitter utils library, which is actually part of the Spark streaming namespace. And we'll obtain a stream of tweets and then begin to produce a D-stream of tweet texts. We define a method that searches for the text, looking for words in the happy words set. And then we use that method to filter tweets we believe are happy and print them to the console. And so when we do that, this is what our output looks like. All right, so let's talk a little bit about real-world task distribution. You've seen some simple examples before that show how easy it is to get started with Spark. But how do you structure your Spark application for real-world task distribution? For starters, RDD operations are similar to the Scala API, but it's important to note that your choice of operations and the order in which they are applied is critical to performance. You must organize your processes with task distribution and memory in mind. The first thing is to determine if your data is partitioned appropriately. A partition in this context is merely a block of data. If possible, you should partition your data before Spark even ingests it. If this is not practical or possible, you may choose to repartition the data immediately following the load. You can repartition to increase the number of partitions, or you can coalesce to reduce the number of partitions. The number of partitions should, as a lower bound, be at least 2 times the number of cores that you're going to operate on the data. Having said that, you'll also want to ensure that any task you perform takes at least 100 milliseconds to justify the distribution across the network. Note that a repartition will always cause a shuffle, which if you're familiar with Hadoop, you know is bad, where coalesce typically won't. So the next thing you want to make sure of is that you filter early and often. Assuming the data source is not pre-processed for reduction, your earliest and best place to reduce the amount of data Spark will need to process is on the initial data query. This is often achieved by adding a where clause. Do not bring in any data that is not necessary to obtain your target result, because this will affect memory and therefore how much data may be shuffled across the network and written to disk. Moving data around unnecessarily is also a real killer and should be avoided at all costs. At each step, you should look for opportunities to filter, distinct, reduce, or aggregate the data as much as possible prior to proceeding to the operation. This is because reducing the memory required to process data is generally vital to performance. But this goes double for large data sets, especially if a shuffle is required. And lastly, use pipelines as much as possible. Pipelines are a series of transformations that represent independent operations on a piece of data, and therefore they do not require a reorganization of the data as a whole, i.e. a shuffle. For example, a map from a string length is independent, where a sort by value requires a comparison against other data elements and a reorganization of the data across the network. Again, shuffle. In jobs which require shuffle, see if you can employ partial aggregation or reduction before the shuffle step, which is similar to the combiner concept in MapReduce. This will reduce data movement during the shuffle phase. And finally, be sure to match the operations to the required task. You should try to create the simplest and most efficient algorithm necessary to answer the question. Here's an example, a simple example, using a query and subsequent filtering to thin a data set. First, we select only the fields we need to perform the analysis, in this case, age and email address. Next, we use a filter to get the over-the-hill demographic. Let's assume this is not the only demographic we are going to process, otherwise we would simply include this filter in the initial SQL statement. And then lastly, we will apply subsequent operations on the data to complete the analysis. Here are some common tasks that are costly and require a shuffle. These operations require the data to be compared against other data elements, which is expensive. It's important to learn the Spark API well to choose the best combination of transformations and where to position them in your job. So that's it. I appreciate your time listening today and look forward to hearing your questions.
That went very smoothly, even with the degree of difficulty of changing into demo mode. So well done. Thank you very much. A reminder, we will take questions from the audience now. Please use the Q&A tab inside of WebEx, and we will be able to get through as many questions as we can. In the meantime, a couple of things that I want to draw your attention to are upcoming webinar schedule. We have next week another analytics-based conversation from Amara Healthcare. And then on August 20th, for those of you looking for production-certified Apache Cassandra and integration with Spark and Solar and things like that, come and learn how to get started with Dataset Enterprise. And then upcoming, we have an introduction to our training sessions as well. If you have not yet visited our free online training course, please make sure to check that out, academy.datastack.com. Lots of ways to carry on your Cassandra learning. And on that note, there is still time to book for our Cassandra Summit 2014. This is the largest gathering of Cassandra users. We're expecting physically in person in San Francisco 1,500 attendees. And then we'll also be live streaming the keynote to meetup groups around the world. So it should be a lot of fun and a ton of great content. Please check it out. So Robbie, questions are coming in now? Are you buckled in and ready to roll?
I am. I will make the caveat that this is something new to all of us. So I would consider myself a Cassandra expert and a Spark newbie, probably with most people using it at the moment, but I will do my best.
Yes, great point there. And actually, just keep asking your questions. If we can't answer one, then it's still really good for us to know the type of questions that are out there because it is so new, and we will try and hunt down an answer for you. Okay, Robbie, so this question from Anurag Sharma. Can we define data processing pipelines for Spark using a DSL? The use case. Users define their KPI using DSL, and Spark does the implementation.
I would say in many ways, Spark is a sort of DSL. It looks like a Scala collection, the Scala Collections API, which one could argue is a pretty good DSL over data analysis, especially if you're familiar with MapReduce. Having said that, theoretically, because it's in Scala and the power of Scala to write DSLs, I do not see any reason why you could not write your own DSL on top of the Spark API and end up with whatever DSL you were looking for. So I don't see why that wouldn't be possible to create an additional DSL.
Okay, great. This one from Billy Lepasana. About performance hits. Is there an extra cost using Spark SQL versus a Scala or Python or Java in terms of performance?
I have not noticed that, but we also have not benchmarked it either. So I would not want to say conclusively that we have noticed a hit. What I will say is that compared to Hadoop, it's much, much faster. So if you're used to Hadoop, then running SQL on Spark is not going to be slower. So that's what I would say. But I would imagine that the hit is small, if there is one, because it should be mostly up front in the parsing. Not knowing a tremendous amount about Spark internals, that would be my assumption.
Okay, great. Nicholas James asks, is Spark Scala only, or does it support Java, Groovy, Ruby, etc.?
It supports, I think I had one slide in there. If I didn't, I meant to, that it supports Scala, Python, and Java out of the box. And we have people here writing closure against it, so I would assume that things like Groovy, since they're JVM-based, could probably, you could probably finagle it to work as well. But as far as first-class citizens, Scala, Python, and Java. However, I would say as a point on that if you're going to use Spark, Scala is, and potentially Python, because Python has a lot of functional concepts as well, but certainly Scala is a much better choice than Java for this sort of work. And I think, in my opinion, what I've advised people to do is, if you're going to spend the time to learn Spark, spend the time to learn Scala as well, because it will make your life much easier.
Great. Is that your top tip of the day?
That's a top tip. My top tip of the day is don't use Java anymore and use Scala. I'm just kidding.
Okay, Todd is asking, when using the Spark shell, why would you not use spark-defaults.conf and add the necessary settings there, i.e. spark.cassandra.connection.host 127.0.0.1? There are a number of these exposed for use in Spark conf and for use within the Spark shell.
You certainly could. My objective with this demo was to show the simplest way to get connected, and so it was not warranted as the best of anything. Simply a quick and easy way to show how to work with Cassandra in the shell.
Okay, great. By the way, I love when I can answer a question, so let me answer this one. Is Spark open source, and where do I find more info? So yes, Spark is an Apache project spun up out of AMP Labs from UC Berkeley here in the Bay Area. There is a company focused wholly on Spark called Databricks. That's founded by the folks from AMP Labs. So on the Apache website, you'll find information. On Planet Cassandra, you will find information specifically about Spark and Cassandra together. To Robbie's point, this is pretty new stuff, so it is evolving very, very rapidly. So with any new technology that evolves rapidly, what you deploy today may very quickly be out of date. So definitely you'll want to stay up to speed on the fast-moving world of Apache Spark. Robbie, don't know if you want to mention any resources you found specifically helpful as you've been looking around.
I think just there's a pretty decent amount of documentation out there. So I would say just Googling questions, but the Spark documentation is pretty good. And then if you're using it with Cassandra, my experience with the Cassandra driver is that the documentation there is very good as well. We didn't really have a tremendous amount of trouble getting up and running. Most of where we have run into trouble is simply understanding what's happening under the hood and making sure that our jobs are efficient. So that's something you'll have to spend some time doing, just as you would to understand how to write MapReduce code.
Great. Shailesh is asking, why did you consider Spark over similar API like storm streaming for Cassandra integration? I actually think that's a really good question. You know, we see a lot of Spark and Storm in the community, but boy, very quickly we're seeing the adoption of Spark really heat up within the Cassandra community. I can't speak, you know, outside of that. But what did you consider something like Storm, Robbie?
We actually did. Last year about this time, we actually built a significant piece of our infrastructure on Storm, and then eventually went away from it for lots of reasons that are probably out of the scope of this conversation. But I would say that at this point in time, one of the things I really like about Spark is how simple it is to bootstrap, how few dependencies it has, and simply the fact that Storm does a few things well, really well, but I think Spark does them just as well with the new Spark streaming framework. And so we didn't talk a lot about streaming, which is really where it competes with Storm. But as far as being able to have one framework to do analysis, batch analysis and streaming analysis, which was very appealing to me and to our DevOps team here, I find that Spark is kind of a one-size-fits-all for those two use cases.
Great. Brendan is asking, can you talk a bit more about Spark's memory requirements versus that of Hadoop for the same task?
So obviously, Hadoop, one of its key attributes is that it spills everything to disk, as I referenced in the talk. So that means that its memory requirements are, you know, lower because it's doing a lot of disk I/O instead of a lot of putting stuff in RAM. So the advantage to that is, of course, you don't need a whole lot of RAM, and disk space is super cheap. But with Spark, you're going to end up needing, and it depends. You know, Spark will overflow to disk if you don't have enough RAM. But if you really want to get the most out of Spark, then you're going to need a lot of RAM. And the easiest way to think about it is, how much data do you want to actually operate on at any given point in time? What do you want to cache in RAM? Because Spark can also cache data sets for future use. And so you'll need to think about that when you plan your Spark cluster. And you know, that's obviously not a one-size-fits-all answer, and it's not necessarily even a direct comparison to Hadoop's requirements, but it does require some thinking through what your data requirements are going to be.
Great, thank you. So how are we doing on time? Doing pretty well. Okay, we'll get through a bunch more here. So Tushar is asking, what are various, actually, sorry, I skipped over one from Masaru here. If you have used mlib with Spark, can you speak about your experience?
Probably not with any authority. We are looking at it now. We have some machine learning use cases that we're very, very interested on getting into Spark, but we're really in the very beginning stages of doing that. So I think I probably could not shed a tremendous amount of light on that.
Great. See that? I think that's the first question where you've had to say that. That's great. We're like 12 questions in. Tushar then, his question, what are various data visualization options with the Spark bundle? So I'll take this one. With DataStax Enterprise, so we work with a lot of different BI vendors to connect to DataStax Enterprise. We are very much of the opinion that we shouldn't build all these different visualization tools. That's not our core competency. So we'll allow you to work with whatever is your visualization tool of choice out of the box. So whatever you can connect to with DataStax Enterprise, you can gain access to Spark as well within that. So those are things like Tableau, Pentaho, Jaspersoft. I'm probably missing a bunch more, but you should be able to find those on the DataStax partner page. Robbie, do you use any visualization tool of choice?
We don't at present. That is actually something we're in the process of evaluating. So I'm very interested in that question myself.
Okay, great. So that may be one, again, that we can come back and answer at a later date as things kind of shake out. Anurag is asking, can Spark communicate with traditional RDBMS as a data source?
Okay, so at the Weather Channel, we don't actually use any RDBMSs, but I believe that, speaking with tremendous amount of authority here, right? I believe that I have seen connectors from Spark to things like MySQL and Oracle. I think I've seen that. So I think the answer is yes, and I'm sure that it must be yes, because I think they have input formats for those data sources, but we don't personally use them here.
Yeah, I was going to say I would be shocked if all the major vendors from RDBMS, so SQL Server, DB2, Oracle, MySQL, Postgres, I'd be shocked if they can't take Spark data. P. Jetty, are there additional memory requirements for Spark when compared to Hadoop? So I think we're getting that question quite a bit, Robbie. There may be a blog post in that somewhere.
Yeah, exactly.
And then I don't know if you can speak to this, but I have a little internal data point. Sahiti is asking, is Spark Cassandra faster than Spark in terms of performance or speed? So let's say, is Spark Cassandra faster than Spark on HDFS, for example? You know, we have some evidence from running internally that Spark and Cassandra are an optimal combination, and you know, some of our internal benchmarks are you know, showing very positively there. Spark itself, though, should perform exactly the same whether it's on Cassandra, the actual queries, whether it's on Cassandra or HDFS. And I don't know, Robbie, if you have witnessed similar stuff there.
Well, it's somewhat difficult maybe to do a direct comparison because our data sets that are in HDFS are not the same data as the ones we have in Cassandra, so we're not running the same jobs on them. But, you know, I would just echo what you said, that at the end of the day, just like Hadoop is creating input splits from a data source, Spark is doing the same thing, and it's doing it in an abstract way where it doesn't necessarily know what the underlying data source is at the end of the day. And so its ability to process that data is not going to be affected by where it got it from.
Right. Shrikant is asking, what is function currying in Scala?
Okay, I can answer the question. It's a bit out of left field, but
I've never even heard of function currying in Scala, so that's yeah.
It's essentially the ability to take a function and split it up, split the parameter list, the argument list, into multiple sets of arguments such that you can call part of the function, and then that becomes a function which can then be applied to the rest of the arguments. I don't know if that was a good explanation, but that's my best on the fly.
We'll see if a follow-up comes from that, but sounded great to me. Gavin, does Spark work well with Cassandra collections?
Yes, I actually did not put this in the presentation because it's pretty easy to see in the driver documentation. It actually works very, very well with Cassandra collections natively.
Excellent, excellent. And let's see here, Andre, considering data replication and a topology with multiple Spark nodes, how does Spark know which server to get data from? In terms of architecture, should it be one Spark instance per Cassandra node?
Yes. So if you remember the slide that I showed where there's each Cassandra node has a Spark worker co-located on it, very much like you would do with Hadoop installation. That's the ideal way to do it, because then the Spark driver, if you kind of look at the driver code, you can see that it's actually doing a similar thing to what the Cassandra Hadoop driver is doing, which is it's grabbing all of the token ranges and figuring out which ones are local, and then getting the data from the local node where possible. So that then follows that co-locating them is the right strategy.
Awesome. So how are we doing on time? 5 more minutes, here we go. Sebastian, by the way, Robbie, tons of questions coming in, hot topic, as we suspected. Sebastian, talking about the weather channel, can you talk a little bit about the volumes of data you handle and what size of Spark Cassandra clusters you're using?
Unfortunately, I cannot talk about that right now. That's something that is still a bit of an internal data point that I would need to get permission in order to relay that information. So unfortunately, I can't answer that right now.
You could tell us, but then you'd have to kill us.
Yes, exactly.
Yeah, let's not do that then. But if you can share that at a later date, obviously, would be great to come back and do another one of these, in a few months' time with a little bit more experience under the belt. Spark appears to be a data parallel framework. How does it deal with parallel processing of a large velocity of data as opposed to parallel processing of a large volume of data? And just a comment from me there, in the Cassandra community, it's been really interesting in the past, I would say 9 to 12 months, to see data sets that traditionally, Cassandra would look at those data sets as very small data sets, but the speed of data coming into the system is incredibly fast. So, I know Spark can handle that very well.
I don't really have any additional comments there. I think you've said it. Spark and Cassandra are a good pairing in that context.
Perfect. So I should tell everybody, by the way, we've got a few questions on this. Yes, this presentation is recorded. We will post the recording and the slides to Planet Cassandra usually within 24 hours, and we will email you when they're available. But you will be able to go through the recording and the slides. Mohammed, does Spark use the Cassandra in-memory option? No, not currently. So the in-memory option within DataStax Enterprise is fairly new, with Cassandra 2.1 coming out very soon, like in the next couple of weeks. We're on the last release candidate. Expect some improvements to DataStax's in-memory option, probably early next year. But Robbie, I don't know if there's anything to add there.
I don't think so, not from my perspective.
Okay, great. Okay, Tushar's saying I skipped his question. Let's see.
I think that was the one about
the visualization, right? Yes, perfect.
Yeah.
Perfect. Okay, great. And then some other questions here in the queue, in the other tab, the chat tab. I'm sure Databricks is going to announce, how many companies have adopted Spark and things like that. But just to reiterate, in the Cassandra community, we are seeing a good uptick of adoption within the established Cassandra community. And then, what I think is fascinating is we're actually seeing a lot of new people looking at Cassandra because it works so well with Spark. So there is no doubt that Spark is a very hot technology and is being adopted very rapidly, probably as rapidly as, or more rapidly than I've seen anything in my time here at DataStack be adopted, which is great. And there is an industry-wide conference. Unfortunately, you just missed it, Anil. It was last month, the Spark conference in San Francisco. I'm sure that was the second one. I'm sure that will be an annual conference and probably a lot of other conferences popping up. But if you are interested in Spark, there are several talks at the Cassandra Summit, which is coming up next month, which are geared around Spark and Cassandra together. And with that, we're right at time. Oh, there's one more from Ann Kelly. Maybe this is to you. Let's squeeze in one more, Robbie.
Okay.
Can I learn Spark on a laptop without attaching to a Cassandra cluster?
You just saw me do it. That would be my answer to that. I had a Cassandra cluster. I had a single node Cassandra running on my laptop, and I ran Spark on top of it. So that was it. You saw it.
Yeah, so definitely check out some of those resources in Planet Cassandra. It is not hard to get a node of Cassandra up and running on your laptop at all. Okay, so with that, Robbie, thank you so much. We really appreciate it. This has been a great webinar, and we look forward to having you back in the future. If anyone is ever in the Atlanta area, Robbie heads up the Atlanta Cassandra meetup group. Reach out to him, and hopefully you can meet in person. So, Robbie, thank you very much indeed.
You're welcome. Thank you very much, Christian.